On a quiet night in Chile, a telescope pointed at the heavens caught something unusual. It wasn't just another star. It wasn't a familiar planet or a passing satellite. It was a moving light, bright, swift, and most importantly, traveling on a path unlike anything we've seen from the countless asteroids and comets in our own solar system. At first, astronomers thought it might be a routine detection, just another icy rock drifting in from the outer edges of the Kuiper Belt. But the more they studied it, the stranger it became. The numbers didn't add up. Its speed was too fast, its orbit was too open, and its direction completely wrong. This object wasn't circling our sun the way planets, asteroids, or comets normally do. Instead, it was just passing through, not bound to us, not from here. A visitor. Astronomers soon realized what they were looking at, a rare interstellar object, something that had traveled across unimaginable distances, perhaps from another star system entirely, before slipping quietly into our skies. This would be only the third interstellar object ever confirmed. The first appeared in 2017, a mysterious elongated shape named ʻOumuamua. It sparked fierce debate. Was it an asteroid, a comet, or something even stranger? Some scientists even considered the possibility of an artificial origin. Then, in 2019, came the second, Comet Borisov. Unlike ʻOumuamua, Borisov looked more like what we expected, a classic comet, complete with a glowing tail of gas and dust. It was clear evidence that comets exist not just in our solar system but throughout the galaxy. And now, the third, 3I/ATLAS, discovered by the ATLAS telescope system in Chile. But this one is different. Unlike ʻOumuamua, it hasn't already slipped away before we had the chance to study it. Unlike Borisov, it doesn't match the usual profile of a comet either. This time, astronomers have caught it early, while it's still close enough to observe. For the first time, we have a chance to examine one of these interstellar visitors in detail. So, what makes it so unusual? To begin with, its path through the solar system is hyperbolic, meaning it isn't looping around our sun, but cutting through space like a stone skipping across water. Once it passes, it will never return. Its speed is so great that the sun's gravity cannot capture it. This is the hallmark of an interstellar traveler. Think about that for a moment. This object is not a native of our solar system. It has journeyed through the void for who knows how long, tens of thousands, maybe millions of years, before finally passing near Earth. And yet, despite that immense journey, it is close enough for our telescopes to study right now. That makes 3I/ATLAS not just a curiosity, but an opportunity. Because every interstellar object is like a messenger from another world. It carries the chemistry, the dust, and the secrets of its home system. Studying it could give us clues about how other stars form planets, and whether the building blocks of life are scattered throughout the galaxy. But with that opportunity comes urgency. These visitors move fast. ʻOumuamua was gone before we could get a good look. Borisov, too, faded quickly into the distance. Now, with 3I/ATLAS, astronomers know the clock is ticking. Every night matters, because once it passes beyond the reach of our instruments, it will be gone, forever. And so, scientists all over the world have begun to mobilize. Telescopes track its every move. Observatories capture every flicker of light it reflects. They run the calculations again and again, searching for clues about its nature and its origin. But what they find only deepens the mystery. It moves faster than almost anything we've studied before. It looks unlike any comet or asteroid we know. And it raises a question that no one has answered yet. What exactly is 3I/ATLAS? Is it just another rock, flung from a distant solar system? Or could it be something we haven't even imagined? In the next chapter, we follow the investigation, how scientists discovered its true origin, the astonishing speed at which it travels, and why its strange appearance has left even experts puzzled. Because the deeper we look into this traveler, the more it begins to feel like a ghost drifting through our cosmic backyard. Astronomers don't just stumble across objects like this by chance. To detect something as faint and fast-moving as 3I/ATLAS requires a delicate balance of technology, patience, and timing. The ATLAS telescope system in Chile was built for exactly this kind of work. Its mission is to scan the night sky for anything unusual, asteroids, comets, or objects that could pose a threat to Earth. It captures wide field images, then compares them night after night, looking for changes. Most of the time, the system flags harmless space rocks or passing satellites. But when 3I/ATLAS appeared in its data, astronomers immediately noticed it was unusual. Its streak across the sky didn't match the typical motion of near-Earth asteroids. Instead of following the predictable curve of an object bound by the sun's gravity, its path was open and hyperbolic. When they ran the numbers, the result was clear. This object was not born in our solar system. To confirm it, scientists measured its speed relative to the sun. Objects within our solar system, even the fastest comets, typically travel below 40 kilometers per second. 3I/ATLAS was moving far faster than that, so fast in fact that the sun's gravity could never pull it back. It wasn't just visiting, it was passing through. And this speed told scientists something else. Objects that wander interstellar space for millions of years are often deflected by the gravity of other stars, whipped around in slingshot motions, or scattered during the birth of planetary systems. By the time they reach us, they are moving at incredible velocities. 3I/ATLAS fits this profile exactly. The next question was appearance. What does it actually look like? Here, the mystery deepened. Unlike comet Borisov, which displayed a familiar glowing coma and long tail, 3I/ATLAS has been harder to classify. Its brightness shifts. Sometimes it looks like a faint comet with traces of dust streaming away. Other times it behaves more like an asteroid, a bare rock reflecting sunlight without much activity. This inconsistency makes it difficult to categorize. Is it a comet running low on volatile material after a long journey? Or is it an asteroid coated with compounds we haven't seen before? Adding to the confusion, its color appears slightly unusual. Observations suggest a greenish tint, likely caused by the presence of cyanogen gas, a substance often seen in comets, but rarely this prominent. If true, it could mean that 3I/ATLAS carries chemical fingerprints from a solar system very different from our own. For astronomers, that's a rare gift. Every spectrum of light they capture, every measurement of brightness, is like a piece of evidence from another world. This isn't just data, it's a sample of alien chemistry delivered directly into our sky. But the challenge is time. Objects like this don't linger. At its current speed, 3I/ATLAS will only remain bright enough for detailed study for a few short months. After that, it will fade into the darkness, heading back into interstellar space, never to return. That urgency has triggered a global response. Telescopes from Europe, North America, Asia, and South America have all turned their gaze toward it. Observatories coordinate in real time, comparing notes, pooling resources, and rushing to gather as much information as possible. There is no room for delay. Unlike a planet or even a long-period comet, which might return after thousands of years, an interstellar object is a one-time encounter. Miss it now, and it's gone forever. But the more they study it, the less straightforward it becomes. Its orbit confirms it is interstellar. Its speed makes sense, yet its appearance doesn't fully match either known category. It's too comet-like to be a simple asteroid, and too asteroid-like to be a fully active comet. It seems to exist in a gray zone between definitions. This has led some researchers to suggest that our current labels, asteroid, comet, meteor, may not be enough. Perhaps in the coming decades, as more interstellar objects are discovered, we'll need entirely new classifications to describe them. For now, though, 3I/ATLAS remains a puzzle, a faint point of light that refuses to fit neatly into our boxes. And that puzzle raises a bigger question. Why are we starting to see more of these visitors now? For most of human history, no interstellar objects were ever confirmed. Then, within just a few years, we've spotted 3. Is it simply that our telescopes are better than ever before? Or could there be something larger at play, something happening in the galaxy that is sending more of these wanderers our way? In the next chapter, we turn to that mystery. Why are interstellar visitors appearing in our skies more frequently? Are they fragments from shattered worlds, rogue wanderers cast out by alien stars? Or could they be part of a much bigger cosmic pattern, one we are only just beginning to glimpse? For most of human history, interstellar objects were nothing more than theory. Astronomers believed they must exist, countless fragments cast loose during the violent formation of stars and planets. Yet, none had ever been seen. The sky seemed quiet, our solar system seemingly isolated. And now, suddenly, in just a few short years, they are appearing. Not 1, not 2, but 3 confirmed interstellar travelers, with whispers of others that may have slipped by unnoticed. So the question becomes unavoidable. What exactly are these visitors? One possibility is that they are fragments of alien solar systems. When stars are born, their surrounding disks of dust and rock collide chaotically. Some material is captured into stable orbits, forming planets, moons, and asteroids. But much of it is flung outward, escaping the pull of its parent star entirely. These fragments, icy shards, rocky cores, even small protoplanets, drift into the void. 3I/ATLAS could be one such shard, a piece of another star's backyard, wandering for millions of years before finally brushing against our own. Another possibility is more dramatic. Some researchers suggest that these objects might be survivors of cosmic catastrophes, planetary systems torn apart by nearby supernovae, or worlds shattered in violent collisions. Imagine for a moment a planet destroyed by the gravity of a giant neighbor, its fragments hurled into interstellar space, each one a messenger carrying traces of a world that no longer exists. It is equally possible that they are what scientists call rogue bodies. Entire planets or large asteroids knocked free from their stars, doomed to drift endlessly between galaxies. While most rogue planets are far larger than objects like 3I/Atlas, fragments of such worlds could easily resemble the small visitors we see today. The variety of explanations reflects a larger truth. Interstellar space is not empty. It is filled with debris, an invisible tide of matter scattered across the galaxy, waiting for chance encounters like this one. But why do we seem to be spotting them only now? The simplest explanation is technology. A few decades ago, telescopes lacked the sensitivity to notice faint, fast-moving objects against the backdrop of stars. The sky is vast, and these wanderers are dim. Even if one passed close, it could easily slip by unnoticed. Today, wide-field surveys like ATLAS, Pan-STARRS, and the upcoming Vera Rubin Observatory scan the skies with unprecedented precision. They can detect the faintest flicker of light, cross-check it against databases, and raise alarms within hours. In many ways, we are only just opening our eyes. Another possibility is that we're encountering them more often, simply because we are looking at the right times. Space is filled with wandering debris, but unless it intersects our orbital neighborhood, we would never know it exists. It may be that the odds are finally aligning, and yet, some scientists entertain a more unsettling thought. What if this sudden uptick isn't coincidence? What if there is a larger galactic cycle at play, an unseen pattern guiding the drift of interstellar material? Stars orbit the center of the Milky Way like runners on a track, their paths crossing and recrossing over billions of years. Perhaps our solar system is moving through a particularly debris-rich region of space, where fragments from ancient systems are more common. If true, then 3I/ATLAS is not an isolated event. It is a symptom of a larger storm of interstellar visitors yet to come. Of course, speculation also reaches beyond the purely natural. Some have asked the question others hesitate to voice aloud. Could any of these objects be artificial? Could fragments of alien technology drift through the galaxy, mistaken for comets or asteroids? Most scientists remain cautious, reminding us that extraordinary claims require extraordinary evidence. So far, all interstellar objects can be explained as natural debris, and yet, the possibility lingers in the imagination. Because if even one were something more, something built, our understanding of the universe would be changed forever. Whether natural or not, their timing is striking. We lived through thousands of years of human history without knowing such visitors even existed. Now, within a single human lifetime, we are beginning to glimpse them with clarity. Coincidence or cosmic signal? These visitors are messengers. Each carries secrets from distant suns, from systems we may never see up close. And each raises the same haunting question: why now? So, what will humanity do with this knowledge? Is anyone preparing to chase these objects, to meet them in the dark? What makes 3I/ATLAS unique compared to those that came before? And most of all, if 3 have already arrived, how many more are on their way? If 3 interstellar objects have already found their way into our skies, what comes next? For now, 3I/ATLAS is still close enough to study. But studying is not the same as reaching. It moves far too fast for any spacecraft we currently have to catch it. By the time a mission could be prepared, it will already be gone, slipping back into the void. Still, the idea of chasing one is no longer science fiction. Agencies like NASA and ESA have discussed missions designed for just this purpose. One proposal, called the Comet Interceptor, is already in development. Instead of targeting a known comet, it will wait patiently in space, ready to launch toward whatever new visitor, possibly even an interstellar one, appears. Think of it as an ambush, a spacecraft lying in wait for the unknown. Other, more ambitious concepts imagine a rapid response probe, small, lightweight spacecraft that could be launched within weeks of a discovery, racing to intercept before the object is lost forever. The technology isn't here yet, but the motivation is growing with every visitor that passes by. So what makes 3I/ATLAS different from the ones before it? ʻOumuamua, the first, was fast and strange, but it was spotted too late. By the time telescopes caught sight of it, it was already leaving, its secrets hidden behind distance. Borisov, the second, was unmistakably comet-like, a frozen body venting gas as it warmed near the sun. It gave us a clear picture of what an interstellar comet looks like. But 3I/ATLAS is unique because we still have time. It is close enough, bright enough, and recent enough to observe in detail. For the first time, astronomers can track an interstellar visitor while it is still here, not just as a fading memory. That makes this a turning point. Not the end of a mystery, but the beginning of a new era, where these encounters may become common enough to study, predict, and maybe, one day, reach. And yet, a larger question lingers. If this is the third, how many more are on their way? Are these truly random wanderers, bits of shattered worlds drifting aimlessly across the galaxy? Or is there a deeper pattern, something guiding these messengers toward us? For now, science leans toward the ordinary, but the possibility of something greater remains, hovering at the edge of imagination. Here on Uncharted Odyssey, we follow these questions because they remind us of something important. Discovery isn't just about looking outward, it's about preparing for the moment when the unknown finally comes to us. Because we don't just look at the stars, we wait for the visitors. Thank you for watching this journey into the mystery of 3I/ATLAS. If you enjoyed exploring with us, make sure to subscribe and join us for the next Odyssey. Because out there, beyond the edge of our solar system, the next visitor may already be on its way.